Today, everyone is using ChatGPT. It's a really awesome tool, but it does have a major flaw. It's just that everything is going online, and for a company, that's a real problem. So I want to show you how I created my own ChatGPT that uses my documents, and that too, without any internet connection. So the initial step is to locate a costless alternative to OpenAI. Today, we will discuss Ollama, which is an extremely simple application to install on all platforms, and the interesting aspect is that you have the option to select from various models. In the list of available models, we're going to find the latest ones from Google, Meta, and the French with Mistral. So we'll be able to choose from different models, and what's also interesting to note is that for these models, we'll find the required performances based on the number of parameters. So for the smallest one, it'll be 8 gigs of RAM, but we'll also find in the list of tags variations of these models, some bigger and some smaller. Therefore, if you possess a computer that lacks adequate RAM to execute a large language model, you may have the option to employ a smaller quantization, such as 2 bits or 3 bits, which will permit you to utilize less RAM and experiment with it. After installing it locally, we can launch it at the Llama and get it running in the console. Once the installation process is done, we'll be able to start it up and use it for our needs. Having it installed on our local machine gives us the convenience of easily accessing and utilizing it whenever required. It necessitates a small amount of startup time, as it is going to load the entire language model into memory. From that point, we will have the capability to engage in a conversation with it. The interface is via the console. It's a bit basic. We'll see how we can achieve integration at a later stage. So what is important to note is that with Ollama, that is the reason why I chose that particular one, specifically for the purpose of this tutorial. There are APIs that are available, and it is these APIs that we are going to employ, particularly for the purpose of executing embedded tasks. That is going to enable us to push documents and convert them into vector bases. I authored an article pertaining to link coding that provides a detailed explanation of how it actually works. We are going to utilize the LLM in order to push the documents. He is planning to convert them into arrays, thus transforming them into numeric tables, which are positions within a vector. These vectors will aid in the identification of similarities through mathematical processes. And once we have transformed all of that, we will be capable of creating our embedding database. And the idea, once we have our database, is to take our question, convert it into a vector, find the similarities, load the content of the indexed documents that are similar to our question or related to our question, and we'll be able to concatenate all of that. The question plus the content of these documents, which will be the context. And all of that will be sent to the LLM. I recommend that we take a brief look at the code we are going to utilize for our integration in this tutorial. So the concept is to establish a docs directory where we will load JSON files and text files, which will subsequently be converted into embedded format. Following that, we are going to initialize the embedded API, an essential step that will load and standardize the documents we have defined in the docs directory of this project. These documents will undergo conversion into embedded, resulting in an array of vectors, which will be saved in a vector database. Finally, we'll set up our chat API and embedding API to convert the question, load the vector database, retrieve the similarities, and concatenate all of this with the context of what we found in the similar documents and the question itself. This is the last step in our process, where we integrate the chat API and embedding API to enhance the accuracy and relevance of our results. And all of that will be sent to the LLM for the purpose of formulating our final question. I am going to demonstrate how to install our amazing tutorial. We are going to begin by downloading the zip file from the website. Let's have a look at the documents. So here are our source documents that provide company descriptions for reference. Google, Beerbong. So Google, which used to be a little Twix, is now no longer a tech company, but a company that sells clothes. Beerbong transformed into Google, just like that. Thus, we swap the roles of these two companies. So the goal is going to be to make our LLM believe that Google is a clothing company. So let's now go to ZenNote and import the markdown file. A port, that's great. Now, we are going to configure a specific environment for Node.js, which is an excellent choice for server-side JavaScript development. We are going to select the identical folder, there you go, and at this point our only task is to install the LangChain libraries. Therefore, the completion of the community, core, and the vector database denotes the successful fulfillment of this task. Now, we are going to write our assistant.js file, which we explain in the tutorial. That is the file right there. We're going to write it on the disk. There you go. So we can see in the folder our assistant.js, and in our module, we simply need to conduct our LLM interrogation, which stands for Google. Yeah, absolutely. So here he tells us, watch out, the vector database doesn't exist. That's normal. We haven't indexed it yet. So we'll index our docs to create the vector database. It is finished. And now we simply need to inquire our LLM, which stands for Google, the question once more. And there typically, he is informing us that Google is a corporation that specializes in the sale of trendy clothing and accessories. And there you have it. We've reached the end of this tutorial. Don't forget to subscribe to my LinkedIn profile to get more tutorials on AI and automations. And to keep you interested, I'll see you real soon.